This is the Algebra 2, Chapter 6b review. We're going to look at sections 6.4 through 6.8, getting ready for the test coming up in a couple days. We did most of the review packet in our class today, so I am just going to scroll through the pages that we've already completed. You can pause the video at any point if you need to take a little more time to look over a question. And then we'll pick up for the last few, and I'll explain how to do the end stuff that we didn't get to in class. All right, the next page was section 6.5. The one comment I did add up here is make sure you show how you checked the solutions on paper. It can't be something you're just doing in your head. So again, pause the video for any of these questions if you want a little more time to look over the solution. We did discuss in class quite a bit question 10 and the idea of the quantity x minus 1 is being raised to a second power and then cube rooted in the equation. And to solve it, we have to undo that. So we have to raise it to a third power, but take a square root. And anytime you're taking an even root, you need to worry about the quantity being negative. So that's why we have the absolute value bars around the x minus 1. All right, the first few questions from 6.6. And then page 3, looking at compositions from section 6.6. And that's where we left off. So we're going to pick up here with question 16. The target for this is I can find the inverse of a function and determine if it is a function. So the first thing we're going to do, we need to switch x and y. So f of x is the same as y, so we're going to switch them. X now is equal to the square root of y minus 2, and then we're going to solve for y. So the first thing I have to do to get rid of that square root is to square both sides. Then I would have to add the 2 to the left side. And then I have to determine if it's a function. So I want you to think about the original function. All right, it's a square root graph that has been shifted to the right 2. So we have this as our basic shape, which does pass a vertical line test. It means it's a function, and we knew that because they wrote f of x. That's telling me it's a function of x. The inverse of that is going to be a parabola that's been shifted up 2. But because we only have the positive branch of our square root, we are only going to have the right side of that parabola. So again, looking at the red graph that I just drew, it would pass the vertical line test, so it is a function. My two explanations, I have two possible options. I can say that the inverse passes a vertical line test, okay? Or I can look at the original and say it passes a horizontal line test, okay? Because if I graph any kind of horizontal line in here, it's only going to hit that black curve once. That means it's passing the horizontal line test. Its inverse will be a function. The last thing I'm going to do here is they're asking me to state the inverse. Since it is a function, I'm going to put it in function notation. So I'm going to say the inverse of f of x is x squared plus 2. All right. For the second example, we have f of x equaling x squared plus 4. If we think of what that looks like, it's a parabola that's been shifted up 4. Okay, so the original is a function. We're going to go ahead and find its inverse. So I'm going to switch my x and y. I would then have to subtract my 4 over. And then I'd have to square root. And anytime we square root, we end up with plus and minus in front of that. Now, is that going to be a function? Well, if we graphed it, it's a square root graph that's been moved to the right 4. But we have the positive branch of it, and we have the negative, or the reflected over the x-axis branch. So that would fail a vertical line test. So we can say inverse fails vertical line test, so it is not a function. Or we could say the original fails the horizontal line test. So again, if I had graphed a horizontal line anywhere through there, we can see that it's not passing that test. It's hitting it in more than one spot. Because it's not a function, I'm going to leave my answer as y equals instead of writing it as f inverse of x, and just leave it y equals plus minus the square root of x minus 4. Anytime you have this situation with the plus minus in front, it's not going to be a function. All right, so take a few minutes. In class, we gave ourselves a rating from 0 to 4 on how well we understood the topics. So take a minute and think through how you did on questions 16 and 17. All right, our last learning target is section 6.8. It says I can graph square root and cube root functions. A couple things in terms of how this is going to be graded on your test. The T-chart that you see, I want you to use for your parent function. Okay? So in question 18, we have a square root in our equation. So my parent function is just the square root of x. For this question 19, it is a cube root. So my parent function is going to be y equals the cube root of x. And then we'll deal with all of the other parts of the equation in terms of the transformations it makes. So the directions say to analyze the transformations. If I look at number 18, I see a negative sign in front. That negative is going to cause me to do a reflection over the x-axis. Okay. Then I look at the 2. The 2 is inside that square root piece with the x. So 2 is a left or right shift. Since it's x minus 2, it's going to go to the right 2. And then the last part of the equation had a plus 3 at the end. That's going to shift it up 3. Okay? So we've identified the transformation. We're going to start by graphing our parent function. For a square root curve, the points that we use for x would be 0, 1, 4, and 9, because those are easy to square root. If we square root 0, we get 0. If we square root 1, we get 1. Square rooting 4 is 2. Square root of 9 is 3. 16 would be the next one in our list, but it's off my grid, so I'm going to leave that off. So 0, 0, 1, 1, 4, 2, and 9, 3. Those are my parent function points. And it does say in the directions to graph the parent function. So I'm going to actually connect those dots, but I'm going to wait for a couple minutes because we need to transform them and I don't want it to get too messy. All right, the directions for our transformations, we said we're going to reflect over the x-axis. So I'm going to take the first point here on the left, the origin. I'm going to reflect it over the x-axis, which actually doesn't move it anywhere. And then I'm going to shift it 2 to the right and up 3. So it's going to land right there. That's going to be the new endpoint to my square root curve. So I'm going to actually just label that. The coordinates of that are 2, 3. The second point, the one at 1, 1, I'm going to reflect over the x-axis. It puts it down here at 1, negative 1. And then I'm going to move it to the right 2 and up 3. I end up with it being right there at the point 3, 2. My third point is at 4, 2. When I reflect it over the x-axis, it's at 4, negative 2. Shifting right 2 and up 3 puts it there. And my last point is at 9, 3. Flipping it over the x-axis puts me at 9, negative 3. Right 2 and up 3 lands me right there. One grid mark away from my graph paper. So my final solution, my final graph would look like that. Making sure you stop there at that endpoint and don't continue beyond it to the left. All right, now I can go back and actually draw in my parent function. I just didn't want to hide the points that I was trying to shift. All right. Then it says to identify the domain and the range. So if we look at the red curve, We said that this endpoint here is at 2, 3. That means all of my x values, the lowest I can get is a 2. And then they move off to the right. I've drawn my red curve to the right of 2. So my domain is x is greater than or equal to 2. My range, I'm starting at 3, but now I'm moving down from there. So my y values would be y has to be less than or equal to 3. All right, looking at our second graph. This one was a cube root. Let's describe the transformations. There's nothing in front, so there's no reflection. The 1 inside with the x, inside that cube root, is going to shift it to the left 1. And then the 2 on the end is going to move it down 2. Okay? To start with our cube root function, our parent function being y equals x cubed, we are actually going to go from -8, -1, 0, 1, 8. We're going to use those values because they're easy to cube root. When I cube root an 8, I get a 2, so cube rooting -8 would be -2. The cube root of 1 is 1, the cube root of -1 is -1, and the cube root of 0 is 0. So plotting those points. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. It's going to look like that sideways twist. And again, I will draw that in, but I'm going to wait till we've moved the points. All right, so shifting. We need to move left 1 and down 2. So every dot, we're going to move left 1 and down 2. All right, so my new curve is going to look like this. And my old curve was just slightly higher. Okay. Domain for this one can be all reals. The range is also all reals. There's no restriction. It looks like it kind of flattens out, but it is continuing to increase as we go to the left and right. So range y equals all reals. All right, our last question. It says to rewrite the function to make it easy to graph using transformations. For us to be able to graph using transformations, we want to have just a plain x with possibly a left and right shift in there. We can have a number out front that affects our stretch or compression. It reflects over the x-axis if it's negative, and we can have a constant outside that moves it up and down. This one has a 4 in front of the x, and we don't want it to be there. So what we're going to do is we're going to factor the 4 out. Now, I'm going to do it in 2 steps. I'm going to factor it out, but keep it inside my square root. So I'm just pulling it away from the x a little bit. Factoring out a 4 from 4x leaves me with an x, and factoring a 4 out of the 20 leaves me with a 5. Then I can split this up.
Linda Dupont to the main office, please. Linda Dupont to the main office.
Sorry about that. All right, so we can split this apart. We've got the square root of 4, and we've got the square root of x plus 5. And we can square root the 4 and get just a plain 2. So this becomes 2 times the square root of x plus 5 minus 7. And now we have it in that transformation format. The 2 is going to cause us to do a vertical stretch by a factor of 2. That means all my y values get twice as high. The 5 is going to shift it left 5, and the 7 is going to shift it down 7. Okay, so make sure you take some time and review these notes before our test, and let me know if you have any questions.